Now we're going to hear about authorization mapper from Hasan and Berat.
Thank you. Hello everyone again. It's a pleasure to be here at BalCCon. Today we will talk about authorization mapper, but in the way that connects code, logs, and security some security topics in authorization mapper. And now to guide you further on this journey, I am honored to hand to stage Hasan, the one who will take us even deeper and deeper. Thank you.
So hi everyone, Hasan here. I'm just like a generic pen tester. There's literally nothing special about me, so I'll just move on to the authorization mapper really quick. So just to give you some background information as to how authorization mapper came to be, as you might know, as applications grow in complexity, authentication and authorizations remain one of the most critical defense layer, because as time moves on and and people keep developing applications, there will be some specific frameworks, maybe for example in Django. So what you have is that you have these specific functions that mitigate traditional injection attacks, maybe like XSS or SQL injection, and then the applications just keep getting hardened and hardened in terms of the traditional web application attacks. That being said, the documentation for the authorization, it shows intent. The traffic shows how people use the application, but the real story, we believe, that lives within the source code analysis. Looking at the code, we believe, is the only way to know where and how access controls are applied within the application itself. And then the detection alone, they're not enough. So you might put on a SaaS tool, you might put all these application security tools, and then they just fire up alerts. But there's no context behind it. So they just read the source code, and then if there's like a predetermined rule that fires up, you just get like a generic alert. And we all know, if you have ever dealt with like a SAST tool, so they just fire up a bunch of false positives, and they're not context aware in terms of the code itself. So with AuthMap, what we try to do is that we correlate code, traffic, and documentation. So we take all these three different sources, and then we try to turn the security alerts into actionable insights that are actually useful. We believe the future of security is continuous code-aware assurance, and then leaving access control maps are essential for these resilient systems. So what we're really hoping to get out of this is the context of the finding that the security tool is firing up is matters and is correlated. So the AuthMap consists of 5 different layers. And for this agent layer, we have 3 agents that are deployed. So the first agent is the code analysis agent, which it extracts routes, roles, and access logic directly from the application source code itself. And then the second agent is traffic analysis agent. So one agent takes the source code and analyzes it, and then this traffic analysis agent observes real traffic patterns, for example, through application load balancers and whatnot. It observes traffic patterns, headers, and anomalies through mirrored logs and ports as well. For the documentation agent attempts to parse API documentation and information. This could be Open API, Swagger, or even like a manual documentation, such as Confluence, for example, is the one that I've seen in a while that developers use. So the documentation agent is going to go and look for what the developers had intended and what they were trying to hope to achieve in terms of authorization mapping. So we have the core analysis engine, and in this engine, we do data normalizations. What we do is that converting raw agent outputs. So the first layer, we got the outputs from the agents, and then we normalize all the data that we have gathered into a unified schema. And then the correlation logic, it cross-validates declared, implemented, and observed states. And then drift and conflict detection identifies mismatches and security policy deviations. So again, from the first layer, that all the data that we have gathered so far is being processed in this engine. And then the confidence scoring assigns reliability metrics to each data source. So this part is more related to how the alert is perceived and how the alert is relayed back to the operator or the user or just like an AppSec engineer. So we have the data and graph layer. So we attempt to centralize data repositories to ensure traceability and advanced analysis based on all the findings that we have gathered and normalized in the previous steps. So with AuthMap, we use PostgreSQL for a relational database, and then we just store normalized route and finding records. We have Neo4j, which is for the graph database. So what we do is that we take all the graph of every user role, and then what that user role can send what requests to which routes, and then these are all presented in a graphical layer. The event streams we have, it could be Redis, Kafka, so it supports asynchronous communication across all of these components. So the user interface, this is where the AppSec engineer or the tool operator sees so what has happened in the backend. We have analyzed the data, we have normalized all the findings, and we're presenting both in a structured way as well as in a graphical way. So for the user interface section, what we have is that the routes and access metrics and the endpoint by role overview across all the sources that we have gathered with this tool. Security drift dashboard is another functionality that highlights inconsistencies and policy gaps. And the traffic heat maps they are displaying usage trends and authentication coverage across the real-life traffic. Reports and findings, you just generate audit and compliance documentation for documentation's sake. So the deployment and integration, we try to make AuthMap as much enterprise ready as possible. Just like that you would just bring out in a tool and then just deploy it across all your CI/CD. So for this, we have containerized microservices. It can be Dockerized, or you can deploy Kubernetes. And AuthMap is aiming to be scalable and just resilient deployment. For the CI/CD pipeline integration, we have automated scanning and continuous code assurance. The security ecosystem integration, we can connect with the CM through syslog or any of the vulnerability management tools for the integration purposes, and audit tools. So AuthMap is like very layered, and then AuthMap actually aims to integrate with the enterprise environment and whatever tools of the enterprise's choices. And then the AI interface layer, it enables contextual understanding of the code and documentation through all of the data that we have gathered. So we did have some challenges while deploying AuthMap, and as of today, not all of them are resolved. And one of the challenges was the high traffic volume. So if you deploy this to a large-scale enterprise environment, let's say that like an e-commerce company, for example, the traffic is just insane. Like there's like hundreds of thousands of requests in a given second, and then you have to actually analyze them to attempt to make sense of what the legitimate users are doing versus if somebody is trying to do something funny. So for the continuous monitoring on mirror ports, they generate huge data streams. Filtering, sampling, or aggregation is needed on our part to avoid performance bottlenecks. And the completion authorization logic, the roles, scopes, and conditional access checks are often hidden in multiple layers of code. Static analysis or the AI-assisted analysis, more often than not, they miss the edge cases or misinterpret business logic, so you might get some false positives that is actually intended role mapping. However, an analyst or like an AppSec engineer would have a really hard time attempting to sift all of these through. The integration overhead, to be useful, AuthMap must integrate with CI/CD pipelines, CM, and ticketing tools. Without seamless integrations, insights and risks staying siloed. So there's lots of enterprise environments, and everybody uses a variety of tools to achieve various purposes. So with AuthMap, we plan to integrate with the environment as much as possible in terms of alerting and triaging. However, that is proving to be a challenging task. Another very important issue is the data privacy and security. So, collecting logs, collecting traffic samples, and attempting to read code snippets means that the AuthMap actually has to analyze and store sensitive data and company proprietary information. So we have to implement strong access controls, and depending on the regional location, you're just gonna have too much problems with compliance teams from all over the world with all over regulations. While we have not solved these issues fully yet, one of the reasons why today we're presenting this tool is to brainstorm some ideas. We know we have some really brilliant AppSec engineers that are attending to this conference. So, maybe at the end of the presentation or after the presentation, since AuthMap is an open source tool anyway, if you have any suggestions, if you have any improvement suggestions, we will be more than willing to talk, because we actually want to build this tool as one of the better open source projects in relation to application security. So, one of our goals is to meet with new people and build like a strong community around it. So, moving on to the real security challenges, authorization logic gets lost in thousands of endpoints and microservices. And developer turnover, which is one of the biggest problems, is people come to join enterprise environments, and then at a certain amount of time they leave. This is a known fact. However, this makes it really difficult for newcomers or the existing developers that are switching from one business unit to another understand the existing authorization model. And security teams lack visibility into whether controls are implemented consistently across services. And then the auditors struggle to verify that access control policies are correctly enforced. Again, this is mainly because it could be because of lack of documentation, a lack of understanding, which is, each and every enterprise application security team has had to deal with these sorts of issues. There's also the problem of shadow endpoints or undocumented APIs emerge in runtime, but are not reflected in design. Again, that's one of the problems, and this could be as a result of lack of communication between different business units, or again, just developers leaving. So all of these challenges makes authorization mapping or truly understanding an application's authorization model really difficult. Alert fatigue, that's pretty another classic one. Your average AppSec engineer has to deal with all sorts of different false positives, thousands of automatically generated alerts, so they get drowned. And then this leaves no time for dealing with authorization mapping and then the attack surface that actually matters. So our proposed solution with AuthMap is that AuthMap normalizes and maps all routes, roles, and authentication checks across code, documents, and traffic. So again, with the agent layer, we take all the possible information that we can get through the documentation, through the source code itself, and then the user traffic. AuthMap also provides a living access control map, so only developers can quickly see how the authorization is structured across the application. We also cross-validate code, traffic, and documentation, highlighting gaps and inconsistencies. So let's say that a very legacy developer built some authorization logic, and then he did some documentation on it, and then he leaves the company, another person joins, but this time he doesn't leave any documentation, but he continues to develop the authorization logic of the application. So AuthMap goes, it checks the source code, it also checks the documentation, and then tries to see if there are any inconsistencies. AuthMap also delivers audit-ready reports with evidence directly traceable to source code and live traffic. So each and every alert that you're going to get within the AuthMap is going to be mapped to either the documentation layer or the source code layer, or maybe even the traffic layer. Not maybe, definitely. So the traffic agent detects real usage and flags endpoints absent in code/docs. So all of these agents are like working with one another to ensure that authorization mapping is one and unified. AuthMap also links alerts directly to the impacted endpoint and role, making them actionable. And then the graph representation, which we use in Neo4j, shows role to endpoint relationships visually and transparently. So you only not get like string-based alerts, but there's also a chance to see in a visualized way that which user role has access to which endpoint and whether if it's intended or not. So our goals and our vision for the AuthMap. So the phase one is to complete the building core and agent infrastructure, and then they generate the first route role map, and then use the documentation agent to normalize APIs and identify missing specifications. For the phase two, which is not so in the near future, but what we're really hoping to do is that implement correlation logic across code, traffic, and documentation. Detect shadow endpoints observed in runtime but missing in the code and documents. Enrich alerts with endpoint and role context to reduce noise and improve prioritization. And for the final phase, it's going to deliver audit-ready reports with traceable evidence. So all you have to do is that you just implement AuthMap, and then it's just going to take care of all the rest. We also plan to provide Neo4j graph visualizations for role endpoint relationships. And then we're planning to integrate with enterprise systems, whether it's a CI/CD pipeline, CM, ticketing tools, to ensure continuous assurance. But just for the current phase, we did push AuthMap to GitHub, which is available. It's free and open source. And then as it stands, it's actually capable to analyze routes and user roles, and it can map it to Neo4j graph. And then before we go, we're just gonna have like a very quick demo of what the future of this project is gonna look like. So you can.
Yes, yeah, what can I look? This is an real data in my company. You can show some issues for critical or medium vulnerability in my company traffic. We get some data in, I don't see, in some agent, for example, source code analyzes agent and dust agent, and you can see this part real life logs in Nginx in my company, and you can see description these attacks, attacks in this part, and attacks part and attacks and endpoint in this in this area you can see, and which attacks to in our applications you can see in this part, and which attack to be in your application, For example, SQL injection or XSS attacks or another attacks you can see, because we get data source code and Nginx web application logs, and we use complicate data in this screen, and you can filter some data. For example, if you can see just critical issues, where is the critical? Yeah. Okay, you can see this section or another severity in attacks. You can see this part, and all of things we can see this interface to attacks and endpoints, and which user type make attack in this time. We can see. Yeah. Any question?
We have a couple minutes for questions. Anyone?
Okay, thank you.
If that is all, please another applause for our presenters.